Assalamu alaikum and hello there, ladies and gentlemen, especially those students who are preparing for the MDCAT examination. We are here with another sizzling episode of the series of 500 definitions from chemistry, and it's going to be our video number 17. We are going to deal with definition from number 21 to 30. It's actually a revision of some of the important definitions that already you have studied in your 2 years FSC course. So let's go straight away for our series of definition. The first definition we have alloy. Alloy is a mixture of metals or of a metal and another element which in combination exhibit a metallic bonding character. We don't depend on a single metal, maybe for the sake of stability, for the sake of strength or luster or some quality, we mixed two elements. But the dominant element is going to be a metal. For example, all these items that you see in the picture, they are made of alloys. Now in common life, the alloys that we use are, for example, bronze or gold or brass or cast iron or sterling silver. You can have many more examples on the Google if you go over there on the internet. So alloy is basically a mixture of two or more elements, especially a metal with another element. We move to another one, which amalgam, which is also a kind of alloy, but it's basically an alloy of mercury with another metal, especially one used for dental filling. So if you've got any friend over there in dentistry, you can go to him and he or she will show you herself or himself what an alloy is. These dentists, they use these amalgam, that is a mixture of mercury with another metal to fill you the cavities over there in your teeth. We move to amphoteric. It's basically it's a substance, a chemical, which tends to behave both as an acid or a base. It has both qualities of both the acid and a base, depending upon the medium in which the species is situated, whether it is in a neutral solution or whether it is in strong acid. For example, sulfuric acid, if we say H2SO4, is a strong acid in water, but behaves more like a base if it is situated among superacids. Next, we go to analytical chemistry. It is the branch of chemistry in which studies and makes use of instruments and methods to separate, quantify, and identify chemical substances. These are basically three purposes of this analytical chemistry. Number one, it separates. Number two, it quantifies as to how much substance over there is. Right? Quantify, it shows you the quantity, and identify, it shows us which chemical substance it is. And nowadays it is making use of different kind of techniques. For example, these are just a few ones. There are many more, but there are some, for example, chromatography or spectroscopy or electrochemistry. Some are already given there in the diagram, and you can see over there in red typing over there. So it's analytical chemistry. We move on to anion, and I found this picture which is something very much suitable, and it shows you both. The definition is anion, but the diagram is showing you both anion and cation. A negatively charged ion, there is an atom or molecule with a net negative electric charge caused by an excess of electron compared to protons. If in a certain particle there are more electrons, so it turns into an anion. That is, it will move towards the anode part of a system. But if there is a loss of electron, it means you have less electron and more proton, it becomes positively charged and it will move toward cathode in a system. We move to Aquaregia, something very interesting, and you can see in the figure a liquid mixture of nitric acid HNO3 and hydrochloric acid HCl, optimally in a molar ratio of 1:3. That is 1 part of nitric acid and 3 parts of hydrochloric acid. When we combine, this is called Aquaregia. And why we use it? Why do we need it in daily life or in practical life? Because it dissolves most of the noble metals, for example gold and platinum. So in order to dissolve these metals, you need Aquaregia, which is a combination of nitric acid and hydrochloric acid in a ratio of 1:3. Atomic number, something very important, but why I included this, because some of the students, they get confused in this atomic number, atomic mass. The number of protons found in the nucleus of an atom of a given chemical element. For example, in helium, we have got 2 proton or 2 electron, so its atomic number is 2. We move to atomic radius, the mean or typical distance from the center of a nucleus to the outermost isolated electron. Something very simple, need no definition. You can see if there's more distance between the nucleus and the outermost electron, so the size of the atom, obviously it's going to be a big one. So the bigger the atomic radius, the bigger will be the size of the atom. Next we have Avogadro number. A little bit extra information from you. I think many of the students, they already know that the number of discrete constituent particles, it may be atoms, it may be ions, it may be molecules, in 1 mole of a substance is called Avogadro's number, and it is simply a number. It doesn't have any units. It is 6.022 or 6.023 multiplied by 10 raised to the power of 23. Who was Avogadro? Actually, his full name was Amedeo Carlo Avogadro, and basically he was an Italian scientist who found out this number. And for your current information, I think it's not something new for you, but each and every number, each and every discovery in each and every branch of science, it has taken a lot of energy, a lot of time, a lot of concentration on the part of different scientists. For example, it's not simply a number. It took this particular scientist a long time to find out this number. Next, we have boiling point elevation. Everybody knows what is boiling point, but what is boiling point elevation? The process by which a substance boiling point is elevated, it increases, it is raised, adding another substance. You can see in the diagram, on the left hand side, we have, this is a pure substance, and on the right hand side, we have got a certain solute that is being dissolved into this solvent, and it is because of this that the boiling point of the liquid, of the mixture on the right hand side, it is elevated, because the particles dissolved in this substance, actually they hinder, they stop the escape of different particles out of the system, and that is why it boils at a higher point, by higher boiling point. Next we have carboxylic acid. It's a classical class of organic acid that contain a carboxyl group attached to a substituent group. Carboxylic acid have the general formula. You can see in the diagram. In the center we have got a carbon which is attached through to the oxygen through a double bond, and on the other side it is attached to a hydroxyl group through a single bond. But on the other hand, that is the third position is taken by some functional group. So this general formula, you can say COOH. It is a symbol of this carboxylic group attached to a functional group which is represented by an R. This is the end of our video number 17. Goodbye for now, and we'll be back with video number 18, in which we will try to explain definition number 31 to 40. Till then, Allah Hafiz.